Greetings and salutations. You are watching episode 14 of Quarantine Distance Learning Algebra 2 Style with Hotard. Today we're going to be learning about sigma notation and arithmetic series. All right, this is the second to last lesson of the school year. So if you've stuck with me this far, then you might as well keep going. I mean, really, quitting at this point would be like being murdered when you're 80 years old. Just hang in there just a little bit longer. Okay, so without further ado, let's get started on algebra. Last time, we were learning about arithmetic sequences. Remember, it's arithmetic if you could add or subtract the same common difference each time to get the next number in the list. So that was arithmetic sequences. Today we will be learning about arithmetic series. Now, a lot of people think a sequence and a series are the same thing, but they're not. A sequence is a list of numbers. A series is the sum of that list of numbers. And in math, sum means what? Add them together. So this first example, find S of 4. Now this is a typo. It's supposed to be S with a just little subscript of 4. It's just the program I was using wouldn't let me type that. But S stands for sum or series. Find the sum of these four numbers. So that's easy. It's just 3 plus 7 plus 11 plus 15. So that's 10 plus 11, 21 plus 15, 36. That's the answer. That's the series, the sum. All right, so nothing hard there. Now, look at number 2. What on earth is that? This is called sigma notation. This little symbol right here, it's a Greek letter called sigma. It means summation. It's a shorthand way of writing a series. All right, it just gives us a formula to get the series. What this is saying is the number on bottom, all right, that's the first number that I would plug in for m in here. So to get the first number, I would do 2 times 1 squared minus 2. 1 squared is 1 times 2 is 2 minus 2 gives me 0. And then I would plug in, I did 1, now I'd plug in 2, and I'd keep plugging it in until I got to this top number, this 5. So I would do 2 times 2 squared minus 2. So 2 squared is 4, times 2 is 8, 8 minus 2 is 6, and then 2 times 3 squared minus 2. 3 squared 9, times 2 is 18, minus 2 is 16, and then keep going. Now how far do I have to go? Until I get to 5. So 2 times 4 squared minus 2. 4 squared is 16 times 2, 32 minus 2 is 30. And then one more, got to do 2 times 5 squared minus 2. 5 squared is 25 times 2 is 50 minus 2 is 48. So this is the sequence that I get from that rule. This is my list of numbers. It's asking for the summation. It's asking us to add all these numbers together. So let's see, just 6 plus 6 is 12, plus 8 is 20. Carry the 2, 3, 6, 10. So the answer is 100. That's the sum of that series. All right, doing the same thing with number 3. All right, this one's a little bit easier. It's a shorter rule. But I'd start with 1, plug in 1 in for n. So I'm going to do 1 plus 200. I'm going to do then 2 plus 200. Then 3 plus 200. Then 4 plus 200. Then, you guessed it, 5 plus 200. And so that's going to give me 201, 202, 203, 204, and 205. And then add it all together. 5 plus 4, that's 9, 12, 14, 15. Carry the 1, so that's a 1. And then 2, 4, 6, 8, 10. So the answer is 1015. That's the sum of that series. Okay, so before we do anything else, I want to make sure you're okay with understanding what sigma notation is. Pause the video, pull up that arithmetic series practice page. I want you to answer questions 1 through 4. Then check your answers on my answer sheet. Make sure you can do this. Then remember the number on bottom tells you what to start with. It's not always going to be a 1. All right, if this had been a 0, you'd plug in 0 first. And you keep going until you plug in 5. If it starts with a 2 on bottom, plug in 2 first. And keep going until you get to that top number. All right, did you do them? Of course you did. Now, look at problem number 4 in the notes. All right, if I tried to work this the same way I work these other examples, This would take me a long time. Why? Because I'd have to plug in 1, then 2, then 3, all the way to 14. For the sake of humanity, there has to be a shorter way to work this. And there is. All right, there is a formula that works for arithmetic series. Now, how can you tell that it's arithmetic? I'll give you a hint. If you look at the two we work together, all right, number 2 that we work together, this one is not arithmetic. I mean, you can tell it's definitely not adding the same number. Number 3, this one did make an arithmetic sequence, an arithmetic series. So just looking at the formulas, what do you think number 2 had that number 3 did not? That would make 3 arithmetic and 2 not arithmetic. There's an exponent. All right, it doesn't matter that there's a number front. If there's an exponent in your formula, it's not going to be arithmetic. Basically, if this is mx plus b, if this is slope-intercept form, like if that had just been 2m minus 2, then it would make an arithmetic series. So this one is arithmetic. I can use the formula for it now. What is that formula for arithmetic series? I'm so glad you asked. I will show you. All right, before I give you the formula, quick little story. All right, story time. Once upon a time back in the 1700s, there's a story that's told about this really smart kid in Germany. He went on to become a famous mathematician. His name was Friedrich Gauss. All right, there's the Gaussian elimination method and all kinds of stuff. I don't want to bore you. But anyways, he had a teacher back when he was just a youngster that decided one day, I don't really want to teach these kids right now. I'm just going to give them an assignment that'll keep them busy for a long time. He told his class, okay, class, I want you to add up all the integers, 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way to 100. One plus 2 plus 3 plus 4 plus 5 plus blah, 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 plus 98 plus 99 plus 100, all the way to 100. You figured that'll keep him busy forever. Well, Friedrich, his classmates got to work on that and worked and worked and worked. This young, bright mind, though, figured out the answer in less than a minute. Now, keep in mind, this is 1700s. There are no calculators. There is no Google. There wasn't even photomath back then. Can you believe it? All right, what did he do to get this answer? Well, I'll tell you. And the method he used, which not only is brilliant, it actually lets us develop a formula for this type of problem. Instead of adding 1 plus 2, and then adding 3, and then adding 4, and then adding 5, if you pair these up, 1 with 100. What's 1 plus 100? It's 101. Now if I do another pair, 2 plus 99, what's that give me? That gives me 101. Now if I pair these, 3 plus 98, that's 101. Every pair comes out to be 101. Now how many pairs would there be? Not 100 pairs. There's 100 numbers, so how many pairs would that be? It'd be 50. It's 50 pairs. Each pair is 101. So to figure out the sum, you could just say 50 pairs times each pair is 101. That'd be 5,050. That's what you get when you add 1 plus 2 plus 3 plus 4 plus 5 all the way to 100. Isn't that clever? Now, what does that have to do with us in our life? We can use the same method to develop a formula. All right, so let's just use this strategy. The sum, S of n, equals the number of pairs times the sum of that pair. So number of pairs, what letter, if you remember our formula from yesterday, what letter do we use for the amount of numbers in the list? It's n. N tells you how many terms are in the list. Now, we want how many pairs. What do you do if there's 100 terms in the list, we had 50 pairs. What do you do at 100 to get the 50 pairs? You divide it by 2. N divided by 2. That's the number of pairs times, I only need to know 2 numbers in my list. All right, which 2 numbers would I need to know in order to figure out this 101? The first number and the last number. Now in arithmetic sequences and series, you remember the notation for the first term? It's A1. And then what's the notation for the last term? It's A of n. All right, this is my arithmetic series formula. It works for any arithmetic series. Now, it only works if it's arithmetic. All right, so let's just add that to our notes right here. Right here on the side, because we're going to be using this formula over and over again. S of n equals n over 2 times A1 plus AN. All right, remember, S stands for sum. If you forgot what any of the letters mean, let's just write it. N is number of terms. A1 is the first term, AN is the last term. So if you know the number of terms in the list, you know the first term, you know the last term, and you know that it's arithmetic, that's important, it means you're adding or subtracting the same number each time, then you can use this formula to solve every sum problem, every series problem. So let's use that for number 4. We said this one's arithmetic because there is no exponent. So I need to know how many terms there are on the list. Well, look at this. If I plug in 1, then 2, then 3, then 4, all the way to 14, how many terms is that? It's 14. N equals 14. Now, I'm not talking about this n. I'm talking about number of terms, n. 14. All right, I need to know A1, the first term. How could I figure out A1? I could plug in 1. So A1 is going to be 4 times 1 minus 6. That's going to be 4 minus 6, which is negative 2. So there's my A1. I need that. And then I don't need to plug in 2, then 3, then 4. What's the only other number I need? I need AN. AN is the last term. So what could I plug in to get that last term? 14. So I'm going to get A of n is going to be 4 times 14 minus 6. So let's see, 4 times 14, then minus 6, going to give me 50. That's A of n. So now I have everything I need to use my formula. The sum of this whole thing is going to be n over 2, so 14 over 2 times A1, which is negative 2, plus AN, which is 50. All right, so that's going to be 14 divided by 2 is 7. Negative 2 plus 50 is 48. So 7 times 48 is going to be 336. Okay, 3 more problems. Stick with me. Number 5. This one is nice. It gives us everything we need for our formula. It's just a matter of plugging it straight into the formula. So the sum equals n over 2. Let me just separate this out so I don't get it mixed up with my work. 14 over 2 times A1, which is negative 11, plus AN, which is negative 89. Gives me everything I need. I just type that straight into my calculator. So 7 times negative 11 minus 89 would be negative 700. That one was easy. All right, 2 more problems. You look at number 6. Now, I want to find the sum. It's asking me to evaluate the series. Now, it tells me A1. It tells me D. What's D stand for again? Common difference. It's what's being added or subtracted each time. And it gives me N. What does it not give me that I need for my formula? It does not give me A of N. But I could use my sequence formula from yesterday. Remember, that was A of N equals A1 plus N minus 1 times D, the common difference. I could use that to find A of n first and then use that, plug it into the sum formula. So let's do that. A of n equals A1 is negative 31 plus N is 9 minus 1 times common difference is negative 7. All right, so 9 minus 1 is 8. 8 times negative 7 is going to be negative 48. No, 56. I lied to you. And then minus 31. Negative 87. Now that's not my answer to the problem. That's A of n. Negative 87. Now I need that to find the sum. So now let's use our sum formula. S of n equals, the sum is going to be n over 2, so 9 over 2. And yes, this formula does work even if it's an odd number. All right, 9 over 2 times A1, which is negative 31, plus AN, we just found, is negative 87. And that's going to give us negative 531. Last problem, negative 531 was the answer. Last problem. All right, this one. It gives me the list. All right, and it asks me to find the sum. Now, it doesn't stop at 59. Don't just add 32 plus 41 plus 50 plus 59. These dots means it keeps going. How many? 18 numbers. All right, so I want to try to use my sum formula. It tells me n is 18. I can tell what a1 is. What's a1? It's 32. There's a1. All right, but can I tell what an is? It's not 59. That's not the last number. All right, it keeps going 18 numbers. So yes, it's adding 9 each time. I could just keep adding 9 and figure it out that way, but it's quicker to use your sequence formula again from yesterday. We need to know an, so I'm going to do the same work I did on the last problem. An equals a1 plus n minus 1 times d. And let's use that. Figure out the last term. So a1 we said was 32. An going to be 32 plus, it told us n was 18 minus 1 times, what's d? What's the common difference this time? It's 9. It's adding 9. All right, so work that out. 32 plus 17 times 9 is going to give me 185. So that's a of n. Again, that's not the answer. That's the last term in the list. I want the sum. So the sum of all those numbers can be n over 2, so 18 divided by 2, which is 9, times a1 is 32, plus an, the last term, was 185. And just work that out. 9 times 32 plus 185, 1953. What an interesting year. All right, so that's arithmetic series. Again, if it's asking for, if it's asking for the series, it's asking you to find the sum. You can use that sum formula. So you'll try the rest of the problems on the practice sheet. Email me with any questions you may have. We have one more lesson to go. I'll see you in a day or two. Bye-bye.